We did state about the translational quantities already. If you would like to convert between the arc distance here, this is the arc that moving. This is the part that this position P moving. So if you look after this as a rigid object, so this point is fixed on this object. When this object rotates, it means this point P moving as well. So you can find the relation between the S here, which is arc distance, this part, to the radial distance. Change the color. Maybe it's looking better in green color. I think so. This is S and this is R. So you have S equal to theta R if you would like convert from theta to S. If you doing dip by dt of S, so that means you have R and you also dip theta by dt. By that dip theta by dt, you have omega. This is from the instantaneous angular speed, right? And diff as well, you have v, which is in this case, this v is your tangential velocity. Right, we not consider about the radial velocity yet, since this is still in the concept of constant accelerations or angular acceleration. So you can also convert from the tangential acceleration, which is in this case, this is the tangential one, tangential, to the angular acceleration, and also omega here as well, omega and alpha, with this P position moving according to the rigid object moving as well, and it's moving with the angular acceleration. Also you can see there's some tangential acceleration that link to the angular acceleration. All this is quite a key. What you're looking after in this conversion, they are all tangential quantities, tangential speed and also tangential acceleration. Now, from that part, as you look carefully about the acceleration that act to that P point, you not only have the tangential acceleration, you also have the radial one as well. This is the radial. Remember about the circular motions? The radial acceleration equal to v squared over r, which is the v is also tangential velocity. Now you know how to find the tangential acceleration, and the c in this case is centrifugal. You learn this word in the circular motion, the centrifugal, which is the acceleration that pointing toward the center of the axis, or point toward in the radial directions. If you would like to sum up, the centrifugal is pointing outward. The centripetal, sorry, my fault, centripetal, that pointing upward. This is your AC. The centrifugal and centripetal are interrelated. It depends on what you're looking after. If you sit on a car and it's yourself looking on how you was acting when you cornering it, the way you pushing outside, is that called the centrifugal force. But what is happened, your body stays still because some frictions, and the friction force that putting toward the central point, we call that as a centripetal force. We did learn about this, but maybe you have to revise in the circular motion part and things that relate to the Newtons. So now look after this part. So if you combine the tangential acceleration with the radial acceleration or centripetal acceleration here and here. So what you have the relation of the R alpha for the tangential. You have the relation of the R omega, which is this is from the V square over R, that from the centripetal acceleration. With this, you can have this form finally for having the resultant acceleration of the object that rotate with some accelerations. So this set of problem that look after the machine or system that is in everyday use, but it seems like this type of compact disc player are no longer uses nowadays. We rather move everything to the cloud system, the internet system. So the physical compact disc is still available, but not many people use it, right? Maybe in the Blu-ray system, which is quite old now, up to date. So let's see. Through this problem, they have some kind like CD or laser readout system, which is this laser gonna point the laser down and read some information and embed underneath the CD-ROMs. And this kind of CD compact disc is rotate, and the rate that is in this case like the constant speed of surface at the point the laser lens system. So this means the way this laser moving to read out all the information from the inside to outside, they're moving with the constant tangential speed. So as it said, Vt in this case equal to 1.3 meter per second. Whether it's still from the inside, which is, I said this is R inside, maybe change with this color, R1 for this one, and the outside is R2, like this. So it's moving from inside to outside. And you would like to determine the angular speed at different positions. So how about the omega at R equal to 23 meter? And how about the omega millimeter R at 58 millimeter? How about this? How can you find the relations to get the information of omegas from these tangential velocity and different radius? Yeah, you can use the information of translational quantities. As you know, the theta can relate to S, which is arc displacement, by you multiply R with theta, R theta, you got S. So if you have the tangential velocity, you have omega and multiply with R, that you have the tangential velocity. How about the tangential acceleration? You have alpha multiply with R, multiplied by R, sorry. So that these are the translational quantities. So you can translate the information from the linear properties to the angular or rotational quantities. Linear quantities and angular quantities. Right, from this information, if you use V equal to omega R, so that if you would like to know omega, have V over R. So what is V? Is tangential. One is 1.3 meter per second. How about R? You know R as the unit of here is the at the first one is 23 millimeter in meter units. So you have this in per second unit, right? Because meter is gone. So you can have in per seconds or radians per seconds, using or instead or. Whether you use this or this is okay. But what is one rev per minute. So this is radian per second, not rev per minute yet. If you would like to convert to rev per minute, you know, is 2 pi as 1 rev. So 2 pi equal to 1 rev. So that these radians per seconds, so that you have to divide by 2 pi in this case. So to convert it, so you have to have 2 pi, and the time that you convert this is in second. If you would like to have in minute, you multiply with seconds. That you mean you divide this part with the minutes, so you got the multiplication with 60. So you have this factor 60 over 2 pi to convert. This is going to be omega that in rev per minute already. So the final results after you sub all this information in is equal to 5.4 10 to the 2 rev per minute. How about another one at another radio positions? So I still use V over R, but R this time is changed to 58 millimeter. So it's 1.3 still meter in seconds. And this part is 58 10 to minus 3 meter. Now it's rev per seconds. This is the unit of rev per second. Not rev, sorry. It's radians per seconds. So you multiply with 60. That means you change per second to per minute. And you divide by 2 pi. So now you change to rev per minute. So to convert this, now you sub all the information and do a calculation. So finally, you will get this information to 22 rev per second, or if it's rev per minute, so you got 2.1 10 to the 2 revs per minute. If you don't want to convert, you can convert it later. So from this calculation, the first one you will have is equal to 57 radians per second. And this one is equal to 22 radian per second. And afterward, you can convert from this, right? You know, 2 pi radians is 1 rev. So that 22 radians, then you have to divide by 2 pi for the revs. And then if you would like to change this second to the minutes, you also multiply with 60, because you already divide with 60 for a minute, 60 seconds in a minute. This is how you convert to the unit that this problem asking, not in radians per second, but in rev per minute. How about another ones? You would like to determine the maximum playing of the standard music. So what is this by this meaning? This may be about the time that is spent for playing things, and how many rev does this evolve. So you have to find the rev or the route that this system involve, but the time that is displayed, so this is delta t, is 74 minutes and 33 seconds. So it's 74 multiplied with 60 and plus 33. So you have 473 in seconds. So you do this conversion first and think about this is still a thing that happened in a constant angular accelerations. So you can maybe just guess things or try about the 4 major kinematics equation, but in this case for angular or rotational, kinematics equations. So I will select the second one. The displacement is equal to the average between initial and terminal velocities and divide by the time difference. Divide by 2, sorry, my fault, and multiply with times. As you know that the playing maximum time here, it means it start from this position here is represent the time that start from 23 millimeter to 58 millimeter. Since we did found the initial velocity, angular velocity, this is one at 23 meter and another one at equal to 58 millimeter already, right? We did found in the previous sub question. And for this omega zeros, it equal to if you cannot remember, just go back quickly, 57 radian per second, and for the outer side is 22. So this is 57 radian per second. This is 22 radian per second. Omega zeros, omega. How about the delta t? You already know, so that you can find the angular displacement. For this case, the delta theta is equal to omega 0, which is 57, plus with 22, and you do average on it and multiply with time, which is 4473. So now you get the angular displacement equal to 1.810 to 5 radians. Now I would like to convert this radian to ref. So as I know, 2 pi radians equal to 1 ref. So I would like to determine this. So delta theta is 1.810 to the 5 and divide by 2 pi. So I change the unit of radian to the ref already. So now it's equal to 2.810 to the 4th ref. Right. Whether you can convert it later or convert by having a factors that 1 ref equal to 2 pi, by multiply with this term, you can change it immediately. So the choice is yours. So you just choose the one that you quite confident and can solve this type of problem easily. How about the next one? Since the time interval before is 4,473 for playing from the first position at R equal to 23 millimeter to R terminal as 58 millimeter. It takes about this time interval. Can you approximate the angular acceleration in this case? You already know the omega for this case, right? And omega for this case, for the first one, this one is equal to 57 radians per second. This one equal to 22 radians per second. You know the omega difference. You know the time interval. Yeah, you can find alpha from the definition of the average alpha. The delta omega by delta t. This is the average. If is this constant, so the average can be equal to the constant angular acceleration here. So the change of the angular speed is omega minus omega zeros by the time interval. So you have 22 radians per second minus 27 and divide by the time, which is 4,473. And finally, you get minus 7.6 10 to minus 3 in radian per sec square. This is the unit of the angular acceleration. And the reasons is have a minus in front of these quantities because you can see the angular speed is reduced. So rather than this is the acceleration of the angular acceleration like this, it's kind of deceleration. So what happened here is slower the speed of rotation. Now we move to another important part, which is about torque. You learn about the force. Force is what acting through the mass of the particle through its center of mass. And then that object moving in linear directions, or maybe in 2D or 3D, is depend on force that the net force interact with it. However, if the net force is not acting through the center of the particle, it may have some rotation, or the thing that happen is torque. If you have a distance d here, which is the moment arm or the perpendicular distance from the rotational axis to the direction of the force, you can see this d, and you have d multiplied with the force. That is what the definition of torque. Since you not yet go through the part of the vector calculation in terms of cross product here, yes, I will explain this later in next chapters. Since you know the operation of cross product, you will learn easily that okay, this torque is vector. So how can you convert the information of vector through the vector operations? But now I will conserve this part. You can look up later if you go through the next chapters and go back to this part, and you have some idea of how to use this type of determination to find the torque as vectors. But from now, just remember these relations. Torque is equal to a force that acting perpendicular to the distance that away from the rotational axis. So you have to determine d and f multiplied with d, you get the magnitude of the torque. But the directions, you use the right hand rule, try to find the final directions. So in this case, I will ignore the term of vector. I will explain to you later, don't worry about that. But this is the definition that I would like to emphasize you from now. Since if you look after in the same plane, the force acting to the object that you're looking after, for example, this wrench, when you try to crank the knot up, you have to have force exert onto this system. In terms of resultant force, if you look after this force, you will see it have two components, right? Along y-axis and also the x-axis. These are the components, and when these two forces combine, you have the resultance of force, and this force multiplied with the, this is mean you have the net torque that happens. So torque can be on the counterclockwise directions. We call these as moments. So it's counterclockwise moments is d multiplied with f1, which is d1 here, and you have also another moments. This is d2 multiplied with f2. The moment and torque is come with the same definition. So if you would like to sum up the net torque or the resultant torque, you have to sum it up, but with different directions, you have different sign on it. So in this case, if f1 d1 larger than f2 d2, the rotation gonna be on this direction. If f1 d1 larger than f2 d2, but however, if the f2 d2 is larger than f1 d1, it's going to rotate in clockwise directions instead of counterclockwise that I said previously. So by this, you can find the net torque and see the directions of the object rotate. If you know the direction is rotate, you can find the angular velocity or angular speed, also the angular acceleration as well. Okay, this is the example. For this example, they have the force, which is T here, is maybe the string tension that bind to it, but in this case, T1 and 2 is another force that acting to these cylinder drums. So if you apply the T1 to the big drum and the T2 to the smaller drum, but this R1 and R2 is bind with the same axis. If you look carefully, the same axis hold these two drums together. The smaller have R2 and the bigger one has R1 in terms of radius. Now, if you like to determine the net torque that happened here, you will look after the definition of the torque. Torque is RF sine theta, right? RF sine theta, where sine theta is the angle between R and F. If you know this type of vector and you translate it, this is the R vector and this is F vector and this is the theta. It's the theta between that position, but in this case, what is happened? If you look after it, you will see R1 and T is perpendicular. R2 and T2 also perpendicular. So that in this case, sine theta is sine 90 degrees, which is equal to 1. So if you would like to determine torque 1, so it's equal to R1 T1. And how about torque 2, which is in this direction, is also equal to R2 T2. If you state that if it's moving counterclockwise in terms of this definition, if I state about X as a reference, so that if it's rotated counterclockwise, I have it a plus sign. But if it's in the clockwise direction, it's going to go with the negative sign. So in this case, you will see R1 and T is wrapping like this. So when it's wrapping like this, that means this R1 moving in clockwise direction. So this is going to come with the negative sign, and with R2 T2 is moving like this. So this is going to be like a positive sign. So I write down as a positive and negative for different torque directions. But if you use the right hand rule for the torque, you will know that the R1 T1 is moving like this, and the direction of torque itself is pointing this direction. This is torque 1 directions. And how about the torque 2? When torque 1 moving like this, torque 2 is wrap things another way around like this. So torque 2 is pointing toward this direction, which is plus z directions here. Can you see it? Here. This is torque 2. So torque 2 is in plus sign and torque 1 is minus sign. So if you like to find the net torque acting on this cylinder about the z-axis, so the net torque, I will write at the magnitude first and I will show about the vector later. The net torque here is you have minus R1 T1 and plus with R2 T2. Now, if you really would like to write it as vectors, you can see this is the axis in J directions, in I directions, and also in K directions. you can see the directions of T1 is pointing backward. So this is in minus k directions. Vice versa, and T2, R2, this one pointing in plus k directions. So you have these in k directions. Since the torque is vector. But if you would like to consider only the magnitude of it, since it's propagate in the same axis, this is fine. And what is unit of the torque? Torque, since R is unit in meter and F is in Newton, so you have torque in Newton meter as a unit. So this is how you find the net torque on the thing that acting to the drum or the cylinder in different side. How about another thing? Now you would like to sub the value in. Since you know T1 equal to 5 newtons, R1 equal to 1 meter, R2 equal to 0.5 meter, and T2 equal to 15 newtons. So with this, can you determine the net torque in terms of quantities that rotating around Z axis as well? So as we did study before, the sigma torque equal to torque 1 plus torque 2, but you also have put the direction into it. So as we know from our right hand rules, if we wrap up with our right hand thumb pointing this wayward, this is for R2, T2, so this is torque 2 directions. For torque 1, R1, if you wrap up your hand with the right hand word, it's going to wrap like this. So this is the torque 1 direction. So you sum up, this is with the minus sign, this is the plus sign. So your T1 is R1 T1 with the minus sign and plus with R2 T2 with the plus sign. And you sub all the value in. For R1 is 1 meter, T1 is 5 newtons, and plus with R2 for 0.5 meter and T2 for 15 newtons. By this, you will find the final results of this calculation is equal to 2.5 in Newton meter unit. Right. This is how you find the resultant or the net torque.